This is the APAC edition of the vBrownbag podcast. I'm Alistair Cook, and it is December of 2015. It has been a very long time since I sat here and recorded this podcast, mostly because I've been busy doing lots of fun other things. Now, the good news is that we have another host for the APAC edition, and his name is Brett. Say hello to the nice folks, Brett. Maybe I should have warned him.
Hello, everybody.
So Brett is based outside of around Melbourne and is going to be helping me to make the APAC edition a little more regular. And so you'll probably hear his voice on a few of these things. The other really nice thing is that I'm getting to hang out with my good friend Lauren Malhoit. Normally we hang out somewhere that neither of us live, whereas tonight we're hanging out, each of us in our own homes, and I just don't get to hang out in a bar with her tonight. Um, so our presenter tonight is Lauren, and we're starting a series that I think is going to be very popular, which is looking into Cisco's SDN product, which is ACI. The great joy is that Lauren is not just a member of the ACI team at Cisco, but she's a member of the vBrownbag team, and so she understands us and what we do. And I'm just going to hand over to Lauren to really run through this ACI stuff that I hear is wonderful.
Well, thanks, Alistair, and welcome, Brett. You guys can see my screen, I assume.
Yes, showing nicely the first slide.
Yep, we see the smug Cisco guy. ACI is so cool. So yeah, we're
And
gonna do.
I got to say, is that actually Joe wearing the unicorn head?
We're gonna start that rumor from now on.
In the past, it was always Ed Sipetch who would wear the unicorn head, but I think it's time for Joe to take up the mantle.
I like that. Yeah, I'm gonna start saying that. Yeah, so as Alistair said, I'm Lauren Malhoit, and I do work for Cisco, so hopefully I know a little bit about what we're talking about here. We're going to fit about an hour's worth of information, or really about 16 hours worth of information you might get in a class in an hour or so here. So feel free to ask questions, let me know. If you have any other questions, and like Al said, there's going to be a series, so anything I don't cover now may be covered in a future episode, if you will. So let's get started. If my slides will move, there we go. All right, so I promise not to throw marketing at you guys. Just want to use this slide to kind of tell you the three things that really go into Cisco ACI. And ACI is application-centric infrastructure, if you guys were wondering that and didn't know. So let's go right to left here. You see the Nexus 9500 and Nexus 9300 switches. Those are required for ACI to work. So we do require the Cisco Nexus gear for ACI. You can also use it in a standalone mode. They come in both. And the cool thing about the Nexus 9000 series switches is that if you want to start off with a standalone switch and then move to ACI, you can actually just download the software and install it on the switch, and then you have an ACI capable switch. So there's no extra or different hardware that you have to buy if you do want to kind of switch modes like that.
So that's useful for me if I'm deploying this out, that I deploy the new hardware out ahead in a legacy configuration mode first, and then I can roll an ACI over top when I'm ready to go live with that.
Exactly. And I will go through, we say legacy, and usually that implies kind of a traditional networking model of 3 tiers, whatever. So I'll kind of go through that too. But yes, exactly, you can absolutely do that, and which can be really helpful for migration, of course. We also have a policy model in ACI. Forgive me, it's 3 a.m. here, so I may be just jabbering on. But the policy model basically means that we are using a declarative model instead of an imperative model. And an imperative model is what we use traditionally in networking and in a lot of other infrastructure, compute, what have you. It basically means that a network administrator needs to be able to log on to any different layer 2 through layer 7 device, so a switch, a router, firewall, et cetera, and give it specific instruction sets for it to do something. And they need to log on to each device usually, or create some sort of script that will do this for them. With a declarative model, if you're familiar with things like Chef or Puppet, it's a declarative language. So we basically specify intent, and we do that using some sort of controller or what have you. and just say what we want the network to look like. And the switches will then configure themselves essentially. So a lot of times we use the example of a pilot. You don't have to tell the pilot what to do in order to land the plane. You just have to tell it, hey, land in this runway, and the pilot knows what to do. So that's kind of what the declarative intent-driven networking, policy-driven networking that we always talk about when it comes to ACI. And then, of course, I mentioned the controller. With ACI, we have an APIC, the Application Policy Infrastructure Controller. So this is basically the brains of the operation. And what the APIC does is it provides a single API that we can use for everything. So when ACI was built, we used an object model for so everything within the ACI fabric is an object, whether it's a hardware node, whether it's a logical object, it doesn't matter. Everything goes through the same API. Whether you're using CLI or using the GUI, everything goes through the API, and the APIs are all open, so you can access things programmatically. We also get a lot of visibility into both the hardware and the software-defined networking stuff, basically. So we have things like health scores, atomic counters. You can see if packets are getting dropped. You can see if the overall health score isn't great, and I'll show you guys that. Reliability basically requires 3 APICs. 3 or 5 APICs, and it's a cluster kind of model. We actually use sharding in order to build this kind of cluster, but everyone laughs when you say sharding, so I'll continue to say cluster. And then, of course, scalability. Basically, it's really easy to add hardware switches to this model. Switches are automatically discovered, and I'll show you guys a little example of that. We can easily copy and paste different objects within the ACI model. So again, it's very scalable. All right, so I was talking about traditional networking before, and this is kind of a very, very simple traditional network, right? But 3 tiers. We have like a core tier at the top, the aggregation tier in the middle, and then an access or distribution tier at the very bottom. It's usually the cheaper switches. We connect all of our endpoints there. But this model was really developed for the north-south traffic. And what we mean by that is something's coming from the outside, going down to an endpoint, and then being sent back out of our network usually. And this was the main traffic that we were getting for the last 20 or 30 years. But that's not really the case anymore. So with things like virtualization, multi-tier applications, all of that good stuff, we're getting more east-west traffic. So more and more people, whether you're using ACI or not, are moving to the spine leaf architecture. It is required in ACI. It's not required in other SDN solutions, but it actually is an optimized way to do it. It's highly suggested that you move to the spine leaf model. And because you can attach your endpoints to a leaf switch, basically, and it's only ever 2 hops away from another endpoint attached to a different leaf switch or even the same leaf switch. So it's going to go up to the spine and then back down out another leaf. The spines in the ACI model know where all of your endpoints are. So it contains that database. As I said, you're going to have 3 or 5 APICs depending on the size of your network. And generally we usually see 3 APICs as it is now. And I should mention the APIC is actually a UCS C series 220 M3 or M4 depending on the latest version is the M4, which is the latest generation of that UCS C series rack mount server. If you are familiar with UCS, then you probably are aware of the UCS manager. Now, we don't use the UCS manager to manage the APICs. It is a separate thing. So there is a hardened, secure image, an APIC image that actually goes on these UCS servers. to bring up your first APIC, this is basically what it looks like. And again, if you're familiar with UCS and you've brought up Fabric interconnects before, it's very similar here. So we have a scripted install essentially, and this is what you're going to see the first time you bring up your APIC. You could either see it, you could like go through the console and all that stuff, but like with UCS, we can actually just have out-of-band management or do some sort of KVM situation to get to it. So just to run through what these things mean in the APIC, and it may not make total sense to you right now, but as I kind of go through, it'll start to make more sense. But I just kind of want to show you how easy it is to bring up your first APIC. So this is literally the entire scripted install that I have covered in this screenshot. So we have the fabric name, ACI Fabric 1, whatever you want to call it, that's suggested. The number of controllers suggested is 3. It says 1 through 9, but it's going to be 3 or 5 as it is right now. The controller ID, so by default it's entering 1 in, and this is, let's say for our purposes here, let's say we're doing our first APIC. You do have to install them in order, so install the first one first, the second one second, so on. When you restart, it doesn't matter. They don't have to be restarted or something. If you upgrade or something, they don't have to be restarted in any certain order, but just that first install they do. Controller name, APIC1, or whatever you would like to call it. The address pool for the TEP addresses. So a TEP is a tunnel endpoint, sometimes called a VTEP, so a VXLAN tunnel endpoint. We are using a VXLAN overlay in our ACI fabric here, and you'll find that a lot of SDN solutions are using VXLAN overlays like NSX. Even Microsoft is trying to move more towards that, although they do use another encapsulation called NVGRE. So our TEP addresses, or our TEP address pool here, by default it's suggesting that we use 10.0.0.0 /16. You don't have to use that, but we do suggest that you use a /16, basically because you want an address pool that's going to be big enough for all of your switches. So if you keep adding more and more switches as your ACI fabric gets larger, you don't want to run out of addresses essentially, because it's going to be a big pain to redo that.
But that fabric is within one physical site, isn't it? This isn't your global network. Yeah.
Right. So this is just, the switches that are actually connected, cabled together, if you will. If you are using that 10.0.0.0/16 subnet somewhere else, especially in your virtualization environment, I would highly suggest using a different subnet here, because technically it shouldn't matter. These TEP addresses are all internal, so it's going to be your VXLAN tunnel endpoints that are basically your infrastructure network. So if you look back at my example here, it's going to be in between the spine and leaf switches essentially. So if you, basically it's your infrastructure network is what we call it.
But it's not going to cause me any technical issues if this is a subnet that I'm going to use for the payload workloads, but it's going to confuse the hell out of my administrators.
Right. No, it shouldn't matter. And there is, and I forget the exact reason, but basically if you're using it in your virtualization environment because of, what's it called, shortest path first or whatever that is, it can cause problems. So you just don't want to overlap it with anything that you're using already. But honestly, your admins don't even really need to know about this. After you do this configuration, as long as you're not reusing this subnet somewhere else, then you can basically forget about it. And I'll show you guys that too. The VLAN ID for the infrastructure network. So again, this is something you don't really need to think about after you set it. Here we're saying 4093 would be a good VLAN ID to assign it. It's really not, though, actually, if you're using anything UCS related, which, if you are a Cisco shop, that's pretty common, because UCS often reserves VLANs from, I think it's like 3796, something like that, in the upper 3000s. So you want to use something below that, and other devices too may have reserved VLANs. So you want to do your due diligence to make sure that you're not, allocating a VLAN ID that is already technically in use by another device or solution that you have in place already. The multicast addressing, it's BD multicast addressing, which stands for bridge domain, and I'll kind of get into the definition of that later. But basically, this is for if you want to use multicast addressing, and you can go ahead and use that default. The out-of-band management configuration, that's really simple. Basically, you're entering an IP address for your out-of-band management for the APIC. Default gateway, same thing. You're entering a default gateway. Speed duplex, you can probably leave that auto unless you're, really fancy and setting up your own speeds and whatnot.
Or really old-fashioned.
Yes, that too. And I believe actually it's recommended to use auto pretty much all the time these days. So, and then of course, if you want to enable strong passwords, you can. I have no there. You should probably click yes because we all want to be very secure. And that's about it. Enter the password for admin. So with that, I'm going to go to my first demo. My first demo is not live. It's a video, but it's just a couple minutes. And I just want to show you how cool it is, the fabric discovery. And I'm sorry I'm using words like cool and I'm like marketing ACI, but it just can't help it. Can't hold back sometimes. So after we set up our first APIC, we can just go to the IP address through a browser. And this is our GUI. This is actually kind of an older GUI. It looks a little different now, and I'll show you that in hopefully my live demo if that works out. So this is the system dashboard, which is what you get when you first log in. There's nothing there right now because I haven't actually connected to all of my nodes yet. So I'll go ahead and hit play here, and hopefully that works. All right, so I've clicked on the Fabric tab at the top. As you can see, it's automatically chosen inventory, and then I'm going to go ahead and choose Fabric membership. All right, so automatically you see a serial number there. It's like TEP-1-101. This is a simulator, so it's kind of using generic serial numbers. But basically, this is the leaf that our APIC is attached to. So it automatically finds that. I didn't have to do any sort of configuration. All I had to do was that scripted install and make sure it was cabled into a leaf, and it automatically found it. So I'll go ahead and just enter a node ID. I'm going to enter 101. It has to start at 101, and we actually recommend just naming all, or the node ID for your leafs should be 10 something, and then I give it the node name of leaf-101. And that's all I had to do. So once I specified my node ID and node name, it found the two spine switches that the leaf was attached to. So my two spine switches appear, and if you look over to the right here, you see roll, and I have one leaf and two spines. Sorry, it's kind of hidden right now, but that roll is automatically discovered as well, depending on the switch and where it is in the fabric. So usually you're going to have Nexus 9500 switch as your spine and a 9300 switch as your leaf switch. All right.
So how are the roles defined? Like, what does it use to discover the role? Is that part of the switch config, or does it just sort of assign it itself?
It assigns it itself. It's based on how the fabric is created. So you're going to have your whole fabric connected, and then also what kind of switch it is. So again, if it's a 9500 switch, it's going to be a spine, and 9300 switch is going to be a leaf switch. And yeah, basically it automatically discovers it. I didn't have to specify anything. So we'll give my spine, my first spine, node ID of 201, and then a node name of spine-201. And this is a naming scheme and node ID scheme that we kind of recommend. It's arbitrary basically, but that's kind of an easy way. The 200s are spines, the 100s are leaf switches. So I've updated, and if you look to the right of roll there, you see that it's getting an IP address automatically. And these are, when we specified the subnet for our infrastructure the top addresses, the tunnel endpoint addresses. And when we said 10.0.0.0/16, that's where it's pulling these IPs from. So it's looking at that as a pool. It's automatically pulling the IPs and assigning the IPs. Nothing we have to do there. In fact, we don't even need to worry about it really ever again. And then you see my second leaf up here. So I only have 2 leaf switches and 2 spines in this fabric. But I'll go ahead and assign it a node ID, assign it a node name, and click update. And that will get an IP address. You can also pre-assign serial numbers. So if you really want to get, I don't know, crazy with it, you could actually pre-assign all of your serial numbers, and it will automatically populate then. So you pre-assign your serial numbers, your node IDs, your node names, and then connect them in later. Say I want to add a switch, I could do it that way. You don't have to. You could do it the way I just showed you to. But again, it's all automatically discovered. So when I talked about scalability, that's kind of one of the things. If I added another leaf and spine switch, it'll automatically discover and add it into my fabric. So any other questions on that part? That's basically the hardware part, and I'm going to go into the logical stuff now.
So I thought it was interesting that the switches, as you're adding them, didn't show you their neighbors until you actually identified them as a node number, or even though they already presumably had that information, it didn't populate up until you'd given them a node number and a name.
Yeah, I honestly don't know what the reason for that is, because yeah, obviously it's all in there. But yeah, that's pretty much how it works.
It's probably just for logical flow in the user interface with no technical constraint in there. It's a human constraint.
Yeah, perhaps. I honestly don't know what the reasoning behind that is. But yeah, and I guess maybe exactly makes it easier for the admin, make sure that they're naming and numbering things correctly. Yeah. All right. So now we'll move on to our logical model. And again, I'm covering a lot of information here, so feel free to stop me and ask questions, but just going to keep going. So, I'm actually just going to build this out. So we have what I consider 3 core constructs in the ACI fabric. At the top we have our root. That kind of covers everything. What's really important here are the tenants, first of all. So we can build in multi-tenancy with ACI. If you're not familiar with that, think of it as, if you're a cloud provider and you want Coke in one tenant and Pepsi in another tenant, it provides that isolation between those 2 tenants. If you're just in, one environment, one little company or something, the tenants could be dev and prod. They could be HR and finance and IT, however you want to split that up, and it kind of just depends. That's something you have to talk through when you're designing it, of course. Below that, we have our private networks, our private L3 networks. So these are layer 3 networks, and what's weird is we can't really decide on a name for these in the Cisco way, so it can be a little confusing. But basically, we call them either contexts, VRFs, so VRFs like a virtual router, or a layer 3 private network. This is kind of our layer 3 construct. You have to have a VRF in there. We call them VRFs in the actual ACI GUI in order to build out our policy model. And then we have bridge domains, which aren't a totally new concept. They're a little bit like VLANs, but essentially a bridge domain holds subnets, and it can hold multiple subnets, as we show there in that second picture. It is a layer 2 concept like a VLAN, except that I could have, well, I'll show you in a demo. And here are just the terms basically that I just described, but for your reference, if anyone's looking through these slides or something later, here's all of it spelled out, I guess. At the bottom there I have endpoint groups, or an EPG, and I'll go into describing this next, but it is basically a container for objects or for endpoints like servers or network devices, anything that you can imagine that you would connect to a leaf switch essentially. And you only connect things to leaf switches. The only things that get connected to spine switches are the leaf switch. So spines don't connect to each other, they don't connect to any other endpoints, et cetera, et cetera. Okay, so we were talking about the policy model in the very beginning. And this is kind of where our policy model comes from the application network profile. And again, if you're familiar with UCS at all, it's not so different from a service profile in UCS. But I mentioned EPGs, endpoint groups, and in this example here, you see the web app and DB endpoint groups. Now, does anyone have web app and DB endpoint groups? Probably not. It's usually like some sort of crazy multi-tiered application that we're working with that has a million different possible endpoint groups. But for the purpose of this example, that kind of makes it easier. And again, endpoint groups can contain anything. We also have contracts in between these endpoint groups, which is basically where the policy comes from. It allows or denies traffic. So in this example, on the left there, I have my clients, and these could be external clients, they could be internal users, what have you. The clients need to connect to the web servers, and they either need to be allowed or denied traffic. They need to go through a firewall, a load balancer, et cetera, et cetera. So the web servers need to contact the app servers. Is it allowed or denied? Then goes through load balancer, and so on onto my database endpoint group. So this is what an entire application network profile is. But let me break it down a little bit more so that it's a little more consumable. So here's my example of just a really simple network. Now, granted, this network doesn't exist anywhere, hopefully, just one router connected to a bunch of servers and laptops, but it'll work for this example. So we never just have a bunch of servers and laptops, right? We have groups of things. So maybe I have my sales people here, my finance people here working on their laptops, and then I have my servers, our web app and DB, and my boxes don't align for some reason there, but that's fine. So we're already doing this kind of segregation using VLANs, right, in traditional networking. That's kind of how we separate things, VLANs and subnets. In ACI, we don't care so much about what VLANs and subnets things are in, which is why we have endpoint groups. So endpoint groups can be anything like said, virtual machines, bare metal physical servers, layer 4 through 7 devices, and they can even be layer 2 or 3 external connections, meaning I can make an endpoint group out of my existing network. So if I'm connecting my ACI fabric and I want it to be able to communicate with my existing network, I can make my entire existing network an endpoint group unto itself and assign policy to that so that I can secure that communication as well as, you know, allow whatever I need to happen in there.
So that
Contracts
would let me
are,
set
again,
up
the policy.
That would let me set up a group
Yep.
of machines. If my network was set up that way, there might be a subnet that contains all of my sales machines, a separate subnet that contains my physical finance machines, and I could build policy based on those, even though they don't connect to an ACI-controlled network.
Yes, yes, absolutely. So yeah, policies, even if they're not, you nailed it. Even if they're not directly in the ACI fabric, I can still add in policies that will all be governed by my application policy infrastructure controller or APIC. So now everything is becoming more and more policy driven. So contracts are a little bit like ACLs, if you'll notice, but a lot easier to set up and can be bidirectional. But basically a contract consists of a subject, and a subject consists of a filter, an action, and a label. Now that's a really confusing way to just say, basically we can allow port 80 or HTTP to communicate between my endpoint groups. So remember, contracts go in between endpoint groups. Now my action there is permit. And my action's probably usually going to be permit because ACI is actually a whitelist model. and I'll go into that in a second. And you can have an optional label. You don't have to have a label. The label is purely for organizational purposes, basically. If I want to kind of search or list all my web access contracts, then I can do it using labels. I don't know how often really that gets used, if I'm being honest, but it's there. So like I said, ACI is a whitelist model. And my little animations here. So I've put 2 servers in my web, EPG, and 3 other servers in my app endpoint group. These little blue boxes are representative of endpoint groups. If you notice, my first server in web is 192.168.10.10, and I'm assuming a /24 subnet there. So 192.168.10.168.10 is my subnet. The other one is a 192.168.20 subnet, but they're in the same EPG. So while these can't communicate with anything in the app EPG by default, they are able to communicate with each other. Even though they're in separate subnets, different default gateways, by default, I can communicate within the EPG. So again, we don't care about IP addressing or VLANs or subnets as long as it's in the same endpoint group. Everything's governed by endpoint groups and policies. So this can open things up a lot. As you can imagine, we don't need to re-IP things constantly or come up with, a new VLAN schema, a new subnet schema, and all that good stuff. Really, we're making it so that IP addresses don't matter that much anymore. Obviously, you still need to have them. Communication needs to happen, but it's all through the EPG. So while I can communicate within my EPG, by default, my web servers and my app servers cannot communicate. Obviously, you're going to want them to communicate somehow. So let's build that out again. And in order to do this, we create a policy or a contract. And again, that goes back to maybe I want port 80 or HTTP to be able to be allowed. And that will then allow my web and app servers to communicate. Okay, so the contract is basically a stateless firewall, which will cover, I don't know what the actual number is, probably 80 to 90% of your use cases, depending on, what kind of company you are and whatnot. We can also stitch in firewalls here if we want, or any layer 4 through 7 service. So if we want a firewall, we want a load balancer, maybe we need stateful inspection, or maybe we need deep packet inspection. In that case, you're going to put in a firewall, right? And firewalls, we can work with many different vendors. When it comes to firewalls, we're partners with Fortinet, Palo Alto, of course, the Cisco ACI's work, and they can be virtual or physical. So we don't care what kind you're using. I mean, there are limitations in that we're only partnered with so many, but we're partnered with a lot of the popular ones, basically. So that, in essence, is what makes up an application network profile. And now we'll go to a demo. And I'm going to try and do this live. And if it's really slow, because as I was telling Al and Brett before, I am VPN'd into San Jose and working on a lab in the Netherlands, so hopefully this works. Any questions before I go into the demo, guys?
I think we're all looking good from the... Yeah, go ahead, Brett.
You mentioned before IP address doesn't matter, and all the examples you've given so far have been IPv4. Just wondering how this would go with IPv6. Yes,
so I want to say I'm pretty sure we do work with IPv6 now. I have to double check on that, honestly. If not, I'm like 80% certain we do work with IPv6, and if not, it's definitely roadmapped. But I'm fairly certain it does.
Cool.
And Lauren's comments at 3 a.m. do not constitute a binding contract with Cisco.
That's right. And if I just said something about the roadmap that I shouldn't have, well, don't tell anyone.
It's only us here.
That's right. Just the internet. All right, so here we have our APIC again, right? This is a newer version, so it looks a little different. This is, I believe, the latest version. Well, we did just announce a newer version, but well, I won't get into that right now because we're trying to stick to the basics here. But again, this is the system dashboard, and this is what it looks like when everything's populated. So you can see at the top I have my system health score, which is 99, which is fantastic, right? That's the overall system health. Down below, I have nodes with health. In this case, I'm saying under 100. So you can see all of my leaf and spine nodes in this lab. I can actually change this to say, hey, show me nodes with health under 84, or whatever you want to show. Same thing with tenants. So I have 4 tenants here. The common, the infra, and the management tenant are all by default there. Common tenant is for things like DHCP, DNS, Active Directory, things that you might have that you want to share throughout your tenants. You may or may not, depending on how isolated, etc., that you need things. And then the other tenant there is just one of my colleagues' tenant. So what I'm going to do, oh, and we have faults over here as well. And these health scores are throughout the GUI, so you'll see as I go through that it's not only here in the dashboard. So what I'm going to do is click on tenants here. Tenants is where most of your configuration is going to take place, probably after initial setup. Fabric is where I set up the fabric in that first demo. VM networking, just to show you guys, we do work with Microsoft, OpenStack, VMware. We just announced Docker compatibility, so you'll see Docker in here as well. So this is where I get all that integration with the VM networking, but we're going to cover that in a future episode. And then the admin tab is for things like setting up health profiles or the regular stuff, LDAP management, adding different admins, you can have different, it's a role-based access control model, so you can have different levels of roles. I can have a tenant admin, I can do read, edit, all that good stuff. So this is a newer version of the APIC, and I'm actually in basic mode if you look over the right here. So there's a basic mode, and where's that? Toggle GUI mode. So I can toggle into my more advanced mode as well if I like. Probably 95% of the configuration you're going to do, again, after initial setup is going to be in basic mode. And I think basically the reason for that is we were getting complaints about the GUI initially because it looked a little complicated. But now it's really kind of fantastic with the basic mode. So I'm going to click on networking here. And there's already some things out there my colleague has out there. But in order to go back to those core constructs I talked about, create a VRF, if you will, or that private layer 3 network, it's a drag and drop. So I drag that, we'll call this vBrownbag VRF. It's kind of up to you. I could call it Coke, Pepsi, Prod, Dev, again, all that good stuff. And I'll just click submit. And I've created a VRF now. And then to create a bridge domain, I'm going to go in. Now notice I can attach it to either VRF depending on what I want to do. I'm going to not mess with my colleagues and do it. Oh, you know what? Let me cancel out of this because I skipped a step here. But that's okay. I am working in the common tenant here. I should be working in my own tenant, so don't make that same mistake as I just did. So we'll call this the VBB tenant. I can add security domains. Again, that's related to who can log into this tenant, basically. And I have checkmark take me to this tenant when I click finish or submit, really. So now I'm in my own tenant, and now I have kind of a clean space to work in. And again, we'll add that VRF. Luckily, I didn't get too far before I realized my mistake. And we'll call it VBB .virf and click submit. So my virf is out there. At least that did give me the chance to show you that I could connect this bridge domain to a different virf if I wanted to. So again, the bridge domain is what contains subnets. Its role is to be a subnet container. I can do one bridge domain for my entire network if I want. I probably won't. I'll probably do multiple bridge domains. And in this case, I am going to show multiple bridge domains. So we'll just call this WebBD. And I'll go to my layer 3 configurations here. And again, we're going to add subnets because that's what this does. So let's do 192.168.10.1/20. Oops. You guys still there?
Yeah, I'm still here.
Okay. Sorry, heard a beep. Okay. So I put in my /24 subnet, and I'm going to click OK. I could add other subnets there if I want, but for this example, I'm just going to leave it alone and click OK. Hopefully. There we go. Okay. And now I'm just going to quickly add another bridge domain, and this is going to be my app bridge domain. And we'll make sure we put in a subnet, 168.100.1/24. So I put different subnets in my bridged domains here. Again, I have my app and my web. So that's all set up. I'm going to click submit, which is a step I also always forget. I think that'll stay anyway, but okay. Now I'm going to go into my application network profile. So I should mention one reason why you would have multiple bridge domains is if you do want to do that, like a stitch in a firewall or something, you do have to go in between different bridge domains. I can't stitch a firewall in between two EPGs that are in the same bridge domain. All right, so the application profile, I call this application network profile in the slides. We kind of go back and forth on the wording on that, but in the GUI it is called an application profile. And I'll just create an application profile here and call it VBB application profile. So the application profile is really just the container for my endpoint groups and contracts. And now that I have created that, I'll click on it, and I will add an EPG. So again, we'll do our web EPG, and click on bridge domains. I've already created those bridge domains, so I'll select the web bridge domain here. Click OK, and do it again for my app EPG. Select my app bridge domain, and click OK. All right, so now I have EPGs. Again, click submit because that's the part I always forget. And so now any endpoints within my web EPG can communicate, like I said. Any endpoints in my app EPG can communicate, but they can't communicate with each other yet. So we need to add a contract. And you'll notice the circles light up. With a contract, we use a provider-consumer model. This is basically, it comes back to promise theory, and ACI, the whole ACI fabric is kind of built on this promise theory model in that I'm not going to go into describing it, and you don't really need to know it, but we do have provider-consumer relationships between our EPGs. So it depends on which one I go to first. Let's say I want my web to provide to my app. So let's say my web is providing HTTP access to the app EPG. You can change it in here, so it doesn't really matter if you get it right, but just kind of showing that. And I'm creating a contract, so I can either create a new contract or choose an existing contract. So there is a way I can go into the GUI and just create contracts if I want. I don't have to do it in this order. And that's the case with most of the constructs in ACI. Order doesn't really matter. We can, because it's all reusable. I can create 2 more EPGs in a different tenant or even in the same tenant, and then reuse the same contract later between those 2 EPGs. It doesn't matter. So that's kind of a nice, I don't know, programmatic, repeatable, all that good stuff, orchestrated, automated, all the buzzwords. So contract name, I'm just going to call this HTTP. No filter, allow all traffic. There's a check mark in there now. So that means everything will be allowed. All sorts of traffic will be allowed between my web and app EPGs if I leave that checked. And the reason you might actually do that to begin with is, let's say if you're migrating from a traditional network to an ACI network, and a lot of people will do kind of a network-centric approach when they first start migrating. So that means they're going to align their VLANs to EPGs essentially. And VLANs don't automatically have these stateless firewalls in between them, so they want to be able to allow all traffic immediately, which is why that's checked by default, basically. But like I said, we're not going to do that. We're actually going to add a filter. And the filter is where I actually specify the protocol, well, let me click inside there, that will be allowed. Again, ACI is a whitelist model, so we have to go through that. So it's a TCP protocol, and then I'm going to go through and select HTTP here. You'll notice I can select any one of those. If I need a different protocol, that's fine. We just need to know the number, and then you can type in the number there. So it doesn't matter. And then you'll see I have like a stateful toggle switch here. So in the case where we're using virtualization, basically, we can have this distributed firewall type of situation where we do offer stateful inspection by simply, putting a check mark in there. But I'll leave that unchecked for now. Click Update. And that's basically it as far as creating a contract. Now, if I do want to, and I don't have the ability to do this right now, but just to show you, if I want to configure a firewall or something to put in there, I would just toggle that switch in, click Next, and then add various options for my firewall. Right now, to include a firewall or a load balancer or something like that, you would get a device package, which is created by the vendor for whatever that device is. And you would add that in, and then all of the features basically that are configurable for that device would be in that device package, and then you can go through and configure it. And again, you can export that code then and reuse that somewhere else too. So really, once you've configured it once, all you have to do to configure another firewall somewhere else is use those same settings and maybe tweak a few things if you need to. So for now, I'm just going to uncheck that and click OK and click Submit. And now I have my HTTP contract in there. I can add more filters. I wouldn't necessarily add more contracts. I would actually add more filters. There we go. And I would do that just by clicking the plus sign here. So if I wanted to add HTTPS as well, I can do that. And I should be able to do that. Oh, let's see. Where? Well, I'm not sure why I can't configure that right now, so we'll just pretend I didn't do that. But you can add in more filters and all that good stuff. So that's pretty much all I had for tonight. Sorry, I know that was a lot of information. Hopefully it was worthwhile. Any questions?
So what we've done is do the initial configuration of a single controller to talk to a leaf-spine collection of switches, and then define the ability for some machines that are presumably a web server to pull their data from the app service. That's the functionality we just put in place.
Exactly.
Cool.
And your endpoints would be attached to the EPGs, either through some sort of static binding if it's a physical server, or through an integrated virtual machine manager domain, which I will show in I think the next part of the series.
Yeah, so the next episode we're going to do in a week's time, because we wanted to get two episodes in before Christmas, and then we'll resume again and cover. You've got 2 more, or have you found more content to keep going with your 3 a.m. wake-ups?
Yeah, I think either 2 or 3 more. I forget exactly what they are,
Yeah,
but
I think
yes,
we had four total.
okay.
But I'm sure we'll find more stuff for you to cover as well.
Yep, and my colleague Mark Snow, he couldn't join me tonight. He is traveling and got his times confused, but he's planning on maybe doing a little bit too. So hopefully you don't only have to hear my 3 a.m. voice.
Yeah, I've got to recommend some more coffee for you to keep you going through into your conference calls in the morning.
Next week I'll be in California, so it'll only be at midnight.
Oh, great. All right, well, thank you, Lauren, for getting us started. I'm sure, given the amount that we got working today, that there'll be lots more over the coming 3 or more episodes. That's been wonderful. Thank you very much, and thank you everybody for joining us. We will go out again in a week's time, which will be, what day is it today? 17th, I think, is when we're on again, and we will see you all then. So this has been the APAC edition of the vBrownbag podcast. We'll talk to you in a week.